Hi everyone, welcome to today's masterclass. Build smarter machine learning with cloud. I am Sagar, your host for this insightful session, and I'm here to ensure you all have a wonderful time. Before we kick off, I would like you all to please drop a quick reaction or maybe an emoji in the chat section. Can I see some quick reactions from all of you? Lovely, lovely, lovely. This is going to be an interactive session, guys. So we request you all to switch on your cameras as well. Lovely to see few faces. All right, let's jump right in. It's my absolute pleasure to introduce our speaker for today, Sasank Panda. Sasank is the CTO at GetWork, Chief Architect at Tentus Technologies, and Head of Research at Saras AI Institute. With 10 plus years in data, AI, and cloud innovation, he advises global AI networks and is a recognized voice in intelligent automations. Let's give a warm welcome to Sasank and get ready to soak in some actionable insight you can use right away. Over to you, Sasank.
Hi, thank you, Sagar. Hi, everyone. So good to see you. Wow, we're almost close to 100 participants. Really excited to see all the great participations. As Sagar said, I'm in this particular field for some time. I know a thing or two about the data analytics, machine learning, and AI. Started my career in 1996 and what is close to 28 years and have worked both on the startup and on the corporate side. I've been worked for a company called WNS. Maybe folks in India they would know as a CTO. Then with Capita and with US, I was with the Ernst& Young, Bearing Point, and also from startup ecosystem standpoint, I co-founded one in India, one in US, one in Germany, and currently I am also with a startup with GetWork, as Sagar said. So today's topic is a little bit more advanced. It's just not the simple AI, but we're going to jump in and speak about the AI or machine learning in the cloud, right? Um, so we're calling how obviously I'm sure that folks on the call they probably have heard about the machine learning. You probably heard about the cloud, but today we're trying to pull both of them together and see how they complement each other, right? And go through a lot of practical examples, in terms of how the organizations are really leveraging both of them to make a difference, right? If you go through the top 10 most valuable companies in the world, right? I think probably all 9 or 10 of them are in IT, right? The most valuable company as of today is a company called NVIDIA. I don't know whether you guys heard about it or not. The second one is, I think there is a fight going on between Apple and Microsoft. And if you just go through the list, right, pretty much all of them are in in IT. And fun thing is that out of 10, probably 9 of them have a Indian origin individual as a CEO of the company, right? And all have been driven by the machine learning, AI, cloud, huge amount of computing power. All that is driving to bring this kind of value to the entire world. So what I'll go through a bit of, we'll start with basics in terms of the machine learning and cloud computing. We spent probably a couple of minutes talking about it and how we can pull them together. Then we'll go through some practical examples in multiple domains. Then you will spend a bit of time in discussing few cloud platforms, right? That you can use, so you can see, and then we'll discuss about bit of a demonstration if I get the time, um, to show how that really works. Yeah. So what is machine learning? Yeah. The simple way of I guess in my mind explaining the machine learning is that it is something the computers can learn without computer programming. So let me walk you through. So let's say if you're trying to decide um, who is qualified to get some assistance, public assistance, for example, right? Or government assistance. You may want to say that the person is either less than 18 years old or more than 70 years old, or the person has less than, let's say, $30,000 of annual revenue, or some we can put some parameters, and you can write a logic, you can write a program saying that if the person is this, then he is eligible for getting the funding. So that is called computer programming. So if you have done any kind of programming in C, C++, COBOL, Python, whatever, that's how the programming language work. But the machine learning, what it does is that it does not use the computer programming. It uses the past data to figure it out, the logic. So what we'll do to machine learning to work, we will load some data, past data, saying that this particular person got the funding, this particular person did not get the funding, and you will load around, I don't know, 10,000 records, and you will let machine to figure it out, the internal logic, right? So, so that's how the machine learning becomes quite effective to us. We don't have to write this if and else logic. We will get the computer to do all that for us, and it all is driven by the data, right? When you and what is making it happen? There is a statistics behind it, right? It goes through the statistics. It figures out what is the percentage of the people at what particular age, particular income is qualified. Based on that, it pulls up the information. This particular logic, it is called the model, right? It's called the model or algorithms, and based on that, obviously, you can make a decision. How it has been used? If you want to buy a house, right? What is the right price of the house? How to figure that out, right? You will use that based on the past data, right? If you are part of a retail industry, right? If you go to a shop, right? How they are going to figure it out, the inventory of a product? How many kilograms of or the pounds of rice you need to store, or how many cartons of milk you want to have, or how many cakes you want to store, right? Because every time you make a decision like that, you are investing some resources, right? If you have too much of it, if you are not able to sell, you are wasting money, or in worst case, you may be losing money because the perishable products may go bad. If you don't have enough products, right, then you will not able to capture the market, right? So how to figure it out, what is the right level of inventory? You can do that based on the past data. We all know that over the weekend, you probably sales are going to be high, so you need to have better inventory. During weekdays, Monday, Tuesdays, generally the traffic is low, so at that time you need to have less inventory. During the holiday sessions, in US Thanksgiving and Christmas, you need to have more inventory. During the month of September, October, probably less inventory. January, February, again less inventory because January, February, the temperatures are not great, or so based on that, you can make the right kind of the decision. Yeah. So you can use machine learning for that, right? Some of the advanced ones, and I will talk about is that. So if you go to a X-ray, if you do X-ray, right, you will get an image of your of the things that you're X-raying on. And rather than having someone to go through the X-ray, make a call whether any kind of the disease, you are susceptible in disease or not, you can go through that X-ray through a machine and let it figure it out, right? It can figure it out based on the historical information it has, and is going to say whether you have, or probability of having a disease is high or low. It can figure that out. So there are so many examples, that we're using on the machine learning. Next one is in the machine learning, very simple. There are a couple of big ones called supervised learnings and unsupervised learning. And obviously, everything is driven by the data, right? Now, supervised learning is where we will tell the data that this was, and going back to my example, whether the person is eligible for the funding or not. We'll go back to the past data and say this particular person was eligible for the funding, this person was not. So that is what we call the level data. We can create a supervised learning. On unsupervised learning, which is a little bit more different kind of concept. So let's say if you have 1 million customers, right? You have a business, you have 1 million customers. You want to run a marketing campaign, right? You don't know how many categories of the customers are there. Yeah. And you don't want to use your bias opinion to create those categories. You want to machine to create those categories for you, right? And you can use the unsupervised learning to go figure out those patterns, and based on that you can get the type of the specific categories for the customer base. One of the ways I explained the supervised and unsupervised learning, in supervised learning, so let's say my sons and daughters are a bit more older now, so I can take an example. So if you're sending a son to a party, right, or to a crowd, to a conference, right? And you can say, that this particular part of the conference, you have more people of the machine learning. They like machine learning. This particular crowd is more around the computer programming. This particular crowd is more on the computer vision, right? And then my son can figure it out which one he likes, and obviously go and have a conversation, right? So that he's going to have a good conference. So that is supervised learning. On unsupervised learning, I will not tell son anything, right? I will basically let him go and figure it out himself, and what kind of the crowd he is going to be associated with, and he's going to have a good conversation, right? So as you can understand, unsupervised learning requires more amount of computing power, but because it figure out the hidden patterns. In supervised, you can do that with a bit more less amount of computing power, but all are done based on the huge amount of data that has been fed to the machine learning models. Now, so that is about the machine learning. Now, let's talk something about the cloud computing, right? On the cloud computing, um, everyone is using cloud computing, right? If you have a Gmail account, if you have stored something on a Google Drive, you are using cloud computing. If you are using Office, Microsoft Office, you have something on the OneDrive, you are using cloud computing. It was not the case, right? 10, 15 years back, it was not the case. And we used to have the shared storages and used to keep the data. Now, cloud computing is just not about having storage. Cloud computing is about having the infrastructure. Now, what is included in infrastructure? Now, your computer is infrastructure, right? In a computer, what you have? You have the memory or storage, you have the computing power, you have networking. Three main components, right? You have the storage, you have the computing power, you have the networking, right? Rather than having your laptop with yourself, if you have a machine that is available on somewhere that you can connect, right? That is called cloud, right? And using cloud, you can get big, powerful machines, right? So let's say if you want a huge, big, 32 core machine that you need to solve for, cloud can deliver that, right? When I started my career, we used to do the projects, right? IT projects. So there used to be two tracks. One is to do the computer programming piece of it, how to write the programs, how to test it, how to make it production ready. There used to have one more parallel track, that is about how to get the servers, how to deploy it, how to make it production ready, right? Sometime, in fact, we used to complete the programming, but the servers used not, they were not ready, because it takes time to buy the servers, provision it, ensure that they are ready to, pick up the load. And nowadays, you don't have to worry about it, because you can get a servers ready, production ready in matter of minutes, not even days. matter of minutes, right? And you have to pay for only the time you're using that particular server. You don't have to pay for, you don't have to buy the entire equipment, right? All this is possible because of the cloud computing, right? I would say around 10 years back, there was some it was a bit hesitant. People are a bit hesitant in terms of using the computing, in cloud computing, right? But nowadays, most of the companies, including the military, they are using cloud computing because it has gained so much of the reputations. There were some challenges in initial days, some leaks and all that, but a lot of the security aspects have been solved, and most of the companies, they have an approach called the cloud first, right? That means if you have to buy a new infrastructure, rather than buying it, they want to use a cloud computing. So what is the benefits of the cloud computing? Is it's a huge amount of scalability, right? So let's say if you're running an e-commerce website, either in Amazon.com or Flipkart.com, right? In a typical month, let's say if you get 1 million users, right? 1 million users in a day. So for 1 million users, you may have X amount of the infrastructure. But during Thanksgiving or Cyber Monday, that 1 million users becomes 4 million users. They will go up 3, 4, 5 times, right? So what to do, right? You have two options. You can buy the machines that can manage 4 million users, right? And keep it idle for 11 months out of 12 months. So you're not really effectively using those machines, or you can use cloud, and it is going to create, it is going to give you that computing power for 1 million users for 11 months and 4 million users for 1 month, right? It can map to your resource requirement. It can scale up, or also it can scale down, right? And it happens seamlessly. You don't have to do anything. It will sense the number of users that are logging in. It is going to automatically provision more servers. Yeah. Flexibility. That means, let's say if you are starting a new project, you want a new computer, you can get it. So there's a project doesn't quite work out, right? Something happened, you want to move on. You can you can shut down the machine. We're done with it. Cost effectiveness, since it is you're renting the machine rather than buying it, yeah, and rather than creating a huge on-premise infrastructure. So when you have an on-premise data center, it's just not about machines, right? You need to have the DBS, you need to have the system admins, you need to have the security, you need to have the real estate to manage all that, right? By having cloud, you don't have to do this, right? That's how you get the cost effectiveness. And lately, in last 5 years, I have seen a massive amount of the improvement in terms of the amount of the advanced tools that are available. In some of the things that hopefully I can demo today, where you can see you can run the out-of-the-box models on the cloud. That facility is available. You simply have to run it. So cloud platforms, they have the cutting-edge machine learning frameworks and tools. So we learned about the machine learning, we learned about the cloud computing. So how they complement each other? How they complement each other, right? Let's talk through that. So let's say you have a data set. That data set has 10 million records, right? You want to run a machine learning algorithm, right? Now, machine learning, the way it works is that there are two different components of it. One is the using the machine learning. Second one is building the machine learning, right? Building machine learning takes a lot of power, lot of computing power. I'm sure that everyone might have used OpenAI, right? To build the OpenAI model, right? It has close to over 1 trillion tokens. That probably took a huge amount of computing power, huge amount of time, probably 3, 4, 5 months to get that model ready. As a user who are using it, we can use it quite easily, right? Now, so in terms of during machine learning, during learning time, you need a huge amount of the computing power, and cloud can provide that computing power, right? So you can use the cloud computing or cloud infrastructure for the machine learning, and you can see there is a seamless integrations of the cloud services, right? You don't need to really do a lot of manual work to put the algorithm on the cloud. a lot of the cloud providers like Azure, AWS, and GCP, they have done a lot in terms of improving this, right? Improving the integration between the machine learning model and the cloud, to the extent that in some cases they are calling machine learning as a service. Some of the services that are available that you can use as it is, right? You don't have to do a lot of work. You just provide the data. It can figure it out which model to use, and it can obviously give out the results. And you can have access to the pre-built advanced machine learning tools. So benefits. So you have earlier there was a problem in terms of getting a huge amount of the computing power to train the machine learning models. Now we can do that even with the big data, right? Remember, some time back we used to talk about this Hadoop. Hadoop used to be a big thing. Now still is a big thing, but Hadoop, a lot of the work that Hadoop used to do, that can be managed by the cloud, because the cloud provides the huge amount of the infrastructure. Cost effectiveness, because you're paying on you as you go. You don't have to buy the infrastructure. Obviously, it's cost effectiveness, high amount of the collaborations, and you can deploy faster. So I talked about the cloud computing, I talked about the machine learning, I talked about how they come together, what kind of things you can do. Let's go through some of the domain-specific use cases. So I talked about the healthcare. One of the big one that is going on in healthcare is that how to use algorithms to analyze the medical images, right? Not the simple ones. If once you get older, you'll see, when you get impacted by a disease, generally it's not one disease, you get impacted by multiple ones, right? Let's say your blood pressure goes up, right? And when your blood pressure goes up, you may take some medicines that may impact your immune system. If your immune system goes bad, you may get impacted by something else, right? Generally, the tendency is that, and since our body is obviously dependent on so many parts, if one of the parts is getting weaker, right, other parts of the body gets impacted as well. So at that time, it's very difficult to figure it out. What should you do? First, what happens second, what happens third, right? That's the reason why you see a medical panel, they come together to address the concern, and they have to look at a lot of images to figure it out, what is the right course of the action, right? At that time, you can use the advanced algorithm as a tool to help them. It will not replace the doctors, but it can be used as an enabling tool for the doctors to decide the right kind of the action for that particular diagnosis, right? And sometimes you might have seen, it probably happens in all parts of the country. Doctors, they don't have time. The number of patients versus number of doctors, the ratio is obviously not in favor of us, right? Now, if you're able to provide any kind of support to the doctors so that they can do a better job, it is good for us. We have seen a lot of the applications in this particular space. If you look at any of the big hospitals, big labs, they use this, right? It is inbuilt in their machine now, right? When they look at it, in fact, when you do a image, it throws out a report. Potentially, you need to look at these hyperparameters, right? These parameters, and that maybe even you can see it if it is allowed to see that these are the things you got to be careful about. Maybe these are some of the preventive actions that you can recommend. Financial fraud. This is something I actually see this thing at least once in a year. Based on of my work, I travel quite a bit, right? Chances are that 1 month I'm in UK, 1 month I'm in US, other month I'm in India, and I do obviously use my credit card. That's how we work, right? And let's say if suddenly, now it happened to me quite a few times, I'll get a call from my bank, automated call saying that we see that there is a transaction in India. Is that you, right? Is that you who made that particular transaction, right? What they're doing is that they are looking at my inherent patterns, right? and figure it out whether that particular transaction is done by me. If a transaction is already done by me in India, for next 3-4 days, you will not see alert, right? Or you'll see a transaction in UK, and the subsequent transactions in UK, they will not see it. Suddenly, you will see the amount of the distance one can travel versus the time taken for between the two different transactions. That may flag, right? Based on the past data, obviously, to figure it out whether it's a fraud transaction or not, right? So this is a big one. And all think about the amount of transaction it is processing. It's processing real time, right? And there's an algorithm that has been used to figure it out. This may be potential fraud target transactions. Let's get a further confirmation on this. Yeah. So it's a big case study. Second one is that risk, right? All of us probably done some sort of investment, some stocks, some bonds, some crypto, whatever is, right? What is the level of the risk tolerance that person can take, right? Let's say you are a young person, your risk tolerance is a bit more high than the persons like me, which is probably going to be a bit more conservative. There are multiple financial models can be run based on the algorithm to figure it out, whether you are eligible for this particular wealth advice or not. Oh, this is a big one. Personalized recommendations. The amount of time, I guess TikTok is banned in India, right? Instagram or TikTok, amount of time that you spend in rolling, so it's not rolling, scrolling. Why is that? Why we are spending so much of time in scrolling? Because TikTok or Insta or nowadays even YouTube Shorts, right? They know what kind of the videos we like. And how do they know? Based on a past history. Now past history means what they do, they have created multiple groups of the clusters, right? So they have scanned through millions and millions and millions of the users. They have created multiple clusters, right? And they, based on your past history, they put you in one of the clusters. And based on that particular cluster, they keep on feeding more and more shots to you, right? That's the reason why we cannot stop scrolling, because they know what kind of content you like. So let's say you're a cricket fan, you'll keep on seeing the cricket stuff. You are a movie fan, you keep on seeing the movie stuff. You like machine learning, you keep on seeing stuff about the machine learning, right? Or if you are a young machine learning related to fashion, they will probably combine all this to send you the feeds that you absolutely like. Yeah. Or if you log into Netflix or Prime, right? You will see what are the movies or what are the serials or the TV shows that you would like, right? That is called the person recommendation machine. Let me go back to the past. The first recommender machine was created by Netflix. Yeah. If my memory serves me right, it is in 2006. In 2006, they actually ran a hackathon, a crowd-based hackathon that ran almost for 9 months, a year or so. They basically say that this is a problem statement. Whoever can solve this particular problem for us will win, like, I think, $250,000, $250,000, right? The first recommender engine came through that, right? So recommendation machines are really great. It improves the customer experience. The other one you might have seen is the demand forecasting. This is for the inventory. Remember the retail example, I talked about it. How much of the inventory you want to have? That is a forecasting as a demand forecasting example. So some of the popular services in machine learning. So I talked about how we can create the machine learning models using your own programming, like say Python, or R or whatever, right? You can obviously learn it. You can create the machine learning. There are some popular services that are inbuilt within the cloud, right? Both, I talked about three main hyperscaler or cloud providers. There are three of them. First one is AWS. They're the market leader. I believe they have 29% of the market share. The second one is Azure, which is around 20%. Google is around 13%, 1-3. Oracle is the fourth one, that is around 10%. All of them have some services that you can use, right? In AWS, you have something called SageMaker. In Azure, you have something called the ML Studio. In Google, you have something called Vertex AI. All the services available, and they're a ready-made service that you can use to create the models, right? You can write the programs, or you can use the drag and drop features to create the algorithms. So how does it work when you try to create the machine learning models in cloud? How does it work? You will upload the data, right? You will upload the data, and you'll spend some time on cleaning the data, right? So in a practical standpoint, the creating the model, fitting the model is probably the easier part because a lot of work has been done. The difficult part is that how to clean the data, right? Generally, when the data gets uploaded on practical standpoint, the data is generally is not clean, which means that you may have a text data in an integer, you may have a integer data in a dead format, or you may have a data that does not have all the values, or you may have the data that has incorrect values, right? For example, you have a data set where the age of a person is there, but suddenly you see age of the person is -50, right? Or the age of person is 300, right? Those data is not accurate. So why that happens? Because since you're dealing with so much of data, the data gets interfaced or collected through multiple systems. When there's a system, you may have challenges with the interface, or if you're someone's entering the data, the data got entered, wrong. There are multiple reasons why the data is not clean. So first thing that you have to do is to clean the data. Cloud has services to clean the data, right? You can put the different kind of rules that is going to clean the data. Once the data is cleaned, obviously you can have that in storage. And after that, obviously, you can run the models, right? Now, to run the models, you can write your own program, or you can use a service like some of the service I talked about, the machine learning as a service models, right? These are the ready-made services that are available that you can use. For example, AWS Rekognition, right? It is a service where you can load the data, load a picture. It will determine what kind of the picture it is, right? If possible, I'm going to demo one of the services. Second one is Cloud Vision, right? It has the vision capabilities. Similarly, you have the Auto ML capabilities in Azure, or in AWS, you have something called AWS Forecast. In AWS Forecast, you just upload the data and say these are my dependent variable, these are my independent variable, right? Based on that, it is going to calculate the dependent variable automatically based on the independent variables. So calculating the price of the house, or the inventory level, or demand forecasting, all that you can do using the AWS forecast. You don't have to write a big Python program, or don't have to do the modeling. It is already available that you can use. Yeah. So going specific to AutoML automates the building of these machine learning models, right? What is the benefit is that you don't need a heavy duty, data scientist who needs to do this. You still need to have people who understands the data, who can clean up the data, who understands bits and pieces of the data science, but you don't need a heavy duty senior, principal architects in the machine learning who can do that. That is the reason why you'll see a huge amount of job requirements for someone who has, decent amount of knowledge, initial years of knowledge in terms of machine learning, because there are already systems available that you can use to create the algorithm like this. You can use AutoML on the cloud to do that. Once the model is you have a model, one of the things that you have to do is that you have to see how accurate the particular model is. You have to evaluate the model, right? Not all the models will be good. You may have multiple models. You have to figure it out which model is accurate or the best suited for your data. All that can be done using cloud because it has a framework. Based on that, it can do the evaluation for you. It can recommend for your data, this particular model is the best. So please go ahead. You can do that using the cloud functionality that is available for the model training and model evaluation. Once you have the model ready, right? The next thing that you have to do is that you have to deploy it. Yeah. Now the model is in the cloud, the data is in the cloud. It's a good possibility that your systems, right, that is going to use the model is in the cloud also, right? For example, recommended systems, Netflix or the TikTok or the Insta, they use cloud, right? If the system is in cloud, data is in the cloud, model is in cloud, so it becomes quite easy to integrate all that, now while doing the deployment, right? And also depending on the usage of the amount of the use that happens, and obviously you can increase the resources or you can reduce the resources. I talked about the cost optimizations because since you don't have to create the models from the scratch, deploy buy the infrastructure for the deployment, it actually creates a lot of cost optimizations. You can optimize the resources. Resources is not about the infrastructure resources. Resources is about the manual, the data scientists, the number of data scientists you need, number of people you need to deploy all this, right? That also can be optimized because you're using cloud resources, you're using the ready-to-use models, and that's the reason why if you go to a job website and look for the amount of the openings, probably the maximum one you will see is the data scientists and data analysis. It is all done keeping the security and the compliance in mind, right? One of the things you got to be extremely careful is about the security and compliance. In US, we have something called HIPAA, right? If it is a medical record, that particular record cannot be leaked to anyone, right? If you do that, obviously, it is going to, you may be penalized, right? Similarly, you may can relate to it something called COPA, right? Anything related to children, right? The data needs to be, you cannot leak, or you cannot identification of the children cannot be leaked to anyone, right? There are very very stringent rules around this. In UK and US and Germany in particular, they have something called GDPR, right? Any data related to any of the citizens of Europe and Germany, the data needs to be stored inside the Europe. It cannot go outside the Europe. And if you don't do it, they will get penalized. I personally know companies, they have gone bankrupt because the data got leaked. The amount of the penalty that you're going to see is humongous. Cloud does that effectively. In fact, all the cloud providers have talked about it. They are certified. They're HIPAA certified, they're COPA certified, they're GDPR certified, so that their security best practices have been incorporated. So is risk management and compliance. Yeah, all that has been done, and also security. 10 years back, 15 years back, I have heard, the different kind of the leaks, right? The big one, anyone is from the US, you might have heard about it. There's a bank called Capital One that had stored a lot of customer data in AWS. I believe in 2012, 2013, there was a leak. Almost a few million records got leaked, right? Through cloud, right? But what happened after that is that there have been so much of the work has been done to improve the security so that you don't see all this now, to the extent that even the military, US military is using it. They have a different kind of the provision, but when they are using it, I believe in Indian Navy is using Azure, the data center that is inside India, right? That is based out of Pune, that is used by the Indian Navy. So the amount of trust has gone up so much that the cloud is being used not only by the private corporations, but by the public, and so is the national security institutions as well. So that kind of concludes my presentation. So meanwhile, if there are any questions I can ask, I need to take a quick minute to log into my AWS so that I can show at least one services about the MLS. Do you see any questions?